Hello everyone. So if you're here, it's because you want to check your work on the 6 problems that we have in our notes. Hopefully you at least attempted it. Remember, you can't get anywhere unless you're trying, and then learning from your mistakes as you complete these problems. All right, so here it says simplify. And so I have this radical that has the number 18 in it. That is the radicand. And this is not simplified because 18 has factors that can be taken out. So we're going to look for the greatest perfect square that will divide into 18. So remember I said you want to start with numbers that are less than the radicand. So we'll start here at 16. Hopefully we all know that 16 doesn't divide into 18. Does 9 divide into 18? And the answer is yes. If you didn't know that, you would just get your calculator and divide it and see which one works. So 18, see if I do 16, it gives me an irrational answer. So that one didn't work. 18 divided by 9, yes. 18 divided by 9 is 2. So those are going to be the 2 factors that I rewrite under my radical. So 9 times 2. Okay, and then I want to separate it because I want to simplify that perfect square. The square root of 9 is 3, and the 2 is already simplified. Why do I keep doing that? I can't draw. Okay, there. The 2 is already simplified, doesn't have any other factors that we can reduce. Okay, so let's try 96. 96 is a bigger number, so I don't expect anyone to have those factors memorized. But if you do, then great job. So let's just go in order. Let's try. Let me see if I can bring my calculator onto the side. Okay, good. 96. Let's start with 81. Okay. 81. Does it work? No. Okay. 64. Nope. 49. Nope. 36 is the next one. That one also doesn't work. 25. We all know that if the number ends with a 5 and your other number doesn't have a 5, it's probably not going to work. 16. 16 worked. So now I come here and I write 16 times, 6? 16 times 6 worked. And so now I can separate those and simplify the 16. And also, if you don't have your square roots memorized, that's also okay. Just go to your calculator. What is the square root of 16? 4 times the square root of 6. And that is it for those. I need to learn how to make these rectangles more straight because I struggle every time. Oh my gosh. All right, let me bring down the perfect squares down here. Okay, so the next one is 5 times the square root of 45. Notice how I said times. Even though there's not a multiplication symbol there, this is being multiplied, okay? It's invisible, but it's there. There's not a plus sign. There's not a minus sign. It's not being divided. It's being multiplied. So I will deal with that 5 at the end. So let's get started with the 45. Which perfect square will divide into 45? Where do y'all want to start? We can start anywhere. I'll just start with the number that's less than 45, which was on our list. It would be 36. So no, that doesn't work. What about 25? Nope. 16? Probably not. 9? Yes, 9 times 5. Oops, pen. 9 times 5 is 45. Okay, so 9 is my perfect square. I want to simplify it, so I'm going to separate it from 5 because 5 will stay inside the square root. And what is the square root of 9? If you know it, it's 3. But remember, I have that invisible multiplication happening here. We can't see it. So the square root of 9 is 3. Square root of 5 stays like that. And then there's just one last step. What is 5 times 3? 15. And it is complete. A question one of my students said, which is a perfect question, is why do we always put the square root on the right side? That's just like a formality thing. An example would be like if we write 2x, we write it like this. We don't write x times 2. The coefficient goes in the front. So that's why we usually put the coefficients or whole numbers in the front of the expression. Okay, so let's do the next one. 3 times the square root of 180. Okay, 180 is a big number. So let's start with, we can start with any of them actually. We got to start with 144. So 180 divided by 144, does it work? No. And this is just a guess and check process, okay? 121 doesn't work. 100 obviously will not work. 81, nope. 64, that didn't work. 49, no. 36, yes, 36 times 5. Okay, so this one is just like the other one. The 3 is being multiplied, but we can multiply that afterwards. Let's reduce the radical first. So the biggest perfect square that divided and was a factor of 180 is 36 times 5. Okay, we want to separate it. And if you start doing these more often, you'll start to skip some steps. Just make sure you stay organized and don't lose what you're doing. So the square root of 36 is 6. And if you don't have that one memorized, Desmos is your best friend. Square root of 36 is 6. 3 times 6. What is 3 times 6? 18. So 18 times the square root of 5. And it is now simplified. Okay. Hopefully it's starting to feel more easier to complete these. But again, if it's okay, if you still need more practice, we just got to keep working on those skills, okay? This one, 5 divided by the square root of 27. So this is illegal. We cannot have a square root in the denominator. Let's rationalize it. So we want to multiply by that same square root in the numerator and in the denominator. Okay, multiply across. 5 is not a square root, so we cannot multiply it, but we can stick it together there. And then in the bottom, we have the square root of 27 times 27. What is that? It's a big number. Oops. 729. Okay, but it's okay. Even though it's a big number, it looks kind of weird. Remember, we did this on purpose because we want to create a perfect square. And the way we do that is by multiplying the same number twice. Okay, so the square root of 729 is going to give you that same number that we multiplied twice. 27. Okay, so we're just going to keep simplifying. So the numerator is still the same for now. And now the 27 is still in the denominator, but without a square root. Because we made a perfect square, we took a square root, and now it is no longer in the denominator. But if you're in my class, I would consider this okay. I think this is enough work. But if you want to keep simplifying this, that 27 here can be simplified even further. So which perfect square would divide into 27? And hopefully you have a close idea out of all these numbers. Which one of these numbers divides into 27? The answer is 9. 9 times 3. So I can actually simplify that 27 even further. And if you were in my class today, we didn't do that step. We're being lazy. So let's just keep going because this is not simplified. 5, and then undo the 9 from under that square root. What is the square root of 9? 3. So we just keep going. This one is actually a long one. What is 5 times 3? Just keep simplifying. 15. Okay. And one last step. This is a fraction. So if we were to leave this fraction like that, it's not simplified. So what factor will divide both of, what is the greatest common factor for 15 and 27? The answer is 3. Both of those can be divided by 3. So actually, we need to simplify this one step further. 15 divided by 3 is 5. And 27 divided by 3 is 9. So we finally simplified this all the way. I promise not to give you something like this on your test or a quiz, because that one was pretty long. But this is a good example to show you all the square root and simplifying steps that we can take. All right, let's do the last one. I'm going to bring this over here. Okay, so this one looks very weird. There's a square root at the bottom. There's a whole number at the bottom. Why are they both there? We don't know, but we need to follow the same steps and simplify this. So let's rationalize first. We don't want that square root of 3 at the bottom. So multiply both by the square root of 3. That allows me to multiply these two because they're both square roots. What is 2 times 3? 6. Okay. What about in the denominator? I have a whole number, I have a 2, and I have 2 square roots of 3. So those together will give me 9. 3 times 3 is 9. And what is the square root of 9? 3. So hopefully you start noticing this pattern that we do when we rationalize the denominator. We end up with the same number, but without the square root here in the denominator. What is 2 times 3? 6. So we actually didn't need any perfect squares for this one. The numbers didn't have to simplify any further than that. And that is our final answer. Okay. I hope you found this video helpful. And if you still need or want more practice, please come talk to me so that we can keep working on these square root skills, because we're going to see them for the next 3 or 4 weeks, working with square roots a lot as we move on to our next topic. Okay, the next thing we'll be learning is Pythagorean theorem. So hopefully you're excited about that. It's one of the easiest, and you probably already seen it one time, maybe not. But yeah, hope you have a great day. See you later.